Alrighty, hey everyone. So I am here a little bit early, just in case anybody can't stay for the full hour or for the whole evening or whatever. So yeah, I just thought I'd get the stream started a little bit early. I am here if you have any questions. Obviously, we're not officially starting for another 15 minutes or so. Now, my computer's clock is a little bit ahead of my phone's clock, and my phone's clock seems to be what most people's clocks kind of agree with. So, um, yeah, so this is going to be a little bit early. I might be off by a couple of minutes here or there with in terms of like the ending time. But yeah, I'm just going to be here hanging out for about 15 minutes and then we will get started unless of course somebody has a question that they can drop in the chat. But in the meantime, I'm just hanging out until somebody shows up. All right, so we are just about at 8 o'clock right now. So, ooh, got some sun in my eyes, which is awesome. So this is review session number 2 for the algebra test. Of course, nobody turned up to review session 1, but that is okay. That's partly my fault for rescheduling it, and also it was so many days before the test that I can understand that nobody had any pressing questions at that time. But now we are the night before the test, so here is the sort of actual introduction to the review session. So it will run for around about an hour. If anybody turns up, if anybody has questions that sort of take us beyond the hour, that's okay. If nobody's here in the last 5 minutes, we might wrap up early. But pretty much, yeah, this review session is going to last about an hour, 8 o'clock to 9 o'clock Dominican time. And the algebra test is tomorrow in class. So I am here to answer any questions that you might have about the test, about the content. No, I won't tell you the questions that are on the test, but I can talk to you about the format of the test. The test is ready and has been sent to your teachers. Um, yeah, so if you have questions about the format, like what you should really be focusing on between the different topics of algebra, the exponents, all of that stuff, I can answer those questions. If there's certain concepts that you're struggling with, put those down in the chat, and if a bunch of you turn up and the chat ends up being super busy, then I'll open up a Q&A in the chat, which is something I've never done before, but it could be interesting. But yeah, I am all yours for the next hour for any questions that you might have about the algebra test. So it is, I've written algebra test here. It is algebra with a little bit of exponents. Hello, we've got people here already. We got 3 of you in sort of viewing, got a message in the chat. But yeah, so I am here for any questions that you might have. And it can be anything about the test, pretty much besides what are the questions. Anything other than that, more than happy to discuss that with you guys. Do I have emojis? Oh, I have emojis too. Awesome. Cool. How are you guys feeling for the test? Good, bad, okay? Bad? Uh-oh. Oh, I doubt that. Is there anything in particular that that you're struggling with? Like any particular section, any particular lesson where you're just like, I'm lost. I have no idea what's going on? Or has it been like that for the whole unit? Everything. All right, cool. Let's go through a little bit of everything. Okay, right back from the beginning then. We'll see if we can sort of do a whole crash course of everything we talked about. Um, Problems with two variables mostly. Okay, so we'll do a very, very quick recap. But before I don't want to start at something too basic if we've only got a limited amount of time. Thumbs up, thumbs down. Do you know what a variable is? Problems with two variables and word problems. Hello. Thumbs up if you, okay, cool. Thumbs up if we know what variables are. Um, Sweet. Thumbs up. I'm going to put this in the chat as well. Thumbs up if you are comfortable with problems with one variable. I'll just wait a sec for you guys to put in your responses. Okay, so thumbs down on that. Okay, thumbs up. So we got some thumbs up, some thumbs down. All right, so what we'll do is we'll start with a little bit on problems with one variable, because the whole idea with problems with two variables is you're trying to turn them into problems with one variable. So if you can do problems with one variable, then that'll help you out a lot with everything else. All right, um, so let's start off with problems with one variable. So something like, let me write one on my whiteboard here. Let's say something like this. uh, Something like that. So we got 7x plus 6 equals 27. So we got just our one variable x, and it only shows up once. So this is about as easy as the problems will get. But we do have a whole bunch of stuff going on this side of the equal sign. It's not just an x by itself. It's attached to this 7 that's being multiplied together, and then you're adding this extra 6 on. There's a whole lot of stuff going on the left side of the equal sign, right? So um, what you need to do when you're dealing with a problem like this, you can look at this 7x right here, and you can treat it like it's one big object. So you don't want to break it apart just yet. You don't want to break apart these objects that are being multiplied together until they're completely by themselves. So because they're not completely by themselves and we've got that plus 6 added on, what we're going to start with is, I cannot erase while looking at the mirrored version of myself. Um, so what we're going to start with is we want to get rid of this plus 6 over here. So um, so how we do that is, well, I don't want 7x plus 6. I just want 7x on the left side. So in order to get rid of this plus 6, I'm just going to subtract 6 from the left-hand side. All right. But if I just subtract 6 from one side of the equal sign, that's changing the question. That's changing the problem into a completely new one. So what I have to do is, if I'm subtracting 6 from the left-hand side of the equal sign, I also have to subtract 6 from the right-hand side of the equal sign. Now I'm not changing the question, right? Because if you treat the equal sign as balancing a scale on two sides, if you take 6 off one side, you have to take 6 off the other side to keep it balanced. So that's what we're doing here. Now, when you do that, this plus 6 and minus 6, they're just going to disappear, right? If you take something and then you add 6 and subtract 6, it's like you added nothing. So on the left-hand side, we're going to end up with just 7x. And on the right-hand side, we're going to have 27 minus 6, which is 21. So now we're looking at this down here, 7x equals 21. At this point, we've got the 7x by itself on one side of the equal sign. So now what we want to do is we will try and break that up. I don't want it to be 7x. I want it to be just x. That would be the easiest because that'll help me actually solve the problem. So how do I get rid of this x being multiplied by 7? I'm going to divide by 7. I'm going to do the opposite operation. So, um, so in the first step, we were adding 6 in the original problem. So we subtracted 6. We did the opposite of addition. Here we've got x being multiplied by 7. So we're going to divide by 7. We're doing the opposite operation. But again, if I'm dividing by 7 on one side of the equal sign, I also have to divide by 7 on the other side of the equal sign. And then, yeah, we've got it in the comments. On this left-hand side, we've got 7x divided by 7. The two sevens are going to disappear. So we're left with just x. And on the right-hand side, we've got 21 divided by 7, which, as we've got in the comments, is equal to 3. So there we've got x equals 3 starting from that guy up there. 7x plus 6 equals 27. And we get that x is equal to 3. So uh, how is that so far? Are we okay with that so far? I got a thumbs up. I'm hopefully going to see another thumbs up, maybe. Okay, cool. We got a yes. pretty much. Okay. So that's problems with one variable. And if anybody is in the chat and is struggling with it, I'm more than happy to stay past the hour and we can keep talking about that. Um, but so now let's explore an example with two variables. So let me write something down here. So suppose we have something like this. Sweet. We got all thumbs up from everybody who's been active in the chat. Sweet. So let me put down to my worst nightmare is coming up. All right. So I'm going to give you guys the two equations. And if you've got like a notebook or paper or something in front of you, try and work through this problem with me, just because I'm not going to be able to write everything on the whiteboard all at once. So if you can write it out on paper, then that'll help you a lot, I think. So suppose, let's see, if I pick those two numbers. Mhm. Can I do this? No, that's the same. I haven't changed anything by doing that. Okay. Let me make it easy. Let me try not to complicate matters too much. So suppose we have something like this. So here are our two equations. So we've got 2x plus y equals 7. That's one equation. And then the other equation is y equals 4 minus x. So we've got two equations because we've got two variables, right? We got x and y. So in order to solve a problem with two different variables, you need to have two different equations. So there are a couple of questions like this on the test where you've been given the two equations and you need to figure out the two variables. So you don't have to worry about anything there. Now, how do we solve this? So the idea is when you've got these two variables, if I were to look at just one of the equations, if I were to look at just that one, right now, I don't have enough information to figure out what x and y are. I have like a bunch of different options that could work, right? Like if we just ignore this equation here, right? And we look just at that one over there, I've got a bunch of different options that I could like kind of guess. I could say, well, if x is 0, then y would be 4 minus 0, which is 4. But if x is 4, then y would be 0. Like I could figure out one of the variables if I just kind of assign a number to the other one. But basically, I don't have enough information to figure out exactly what they both are with just one equation. And it's the same deal with this one. If we look at this one and ignore that one, it's the same situation. We don't have enough information to figure out what both variables are without a little bit of extra info. So that's why we need the two equations. Now, the first step with the two variable problems, here's the idea is suppose I want to focus on that equation there, 2x plus y equals 7, but I really wish I didn't have to write x's and y's, because if I could write just a bunch of x's or just a bunch of y's, that would help me a lot. That would turn it into a one variable problem, right? And we just did one of those, which we're feeling pretty good about. So if I could write the y using just numbers and x's, or if I could write the x using just numbers and y's, that would help me out a lot. That would turn it into a one variable problem. And we're going to get that from the other equation. So if you look at the second equation, I've said y is equal to 4 minus x. So what does that mean? That means that anywhere that I see a y, I could instead write 4 minus x, because that's what the equal sign is saying, is it's saying that this y is exactly the same thing as that 4 minus x over there. So this question is actually, the way I've made this is a little bit easier than what you might find on the test, because I've already got the y all by itself for you. Sometimes you might have to do a little bit of work, right? If I'd stuck another number somewhere, then you have to do a little bit of work of like adding and subtracting things to get one of the variables by itself on one side of the equal sign. But once we've done that, like is done in this equation right here, what I can do is I can say, okay, from equation, let me turn kind of sideways so I can work and show you alongside. So from equation 2, let's just number it. That's equation 2. This is equation 1. From equation 2, we know that y is equal to 4 minus x. So what I'm going to do is I'm going to take that information and I'm going to plug it into this equation over here. So we've got 2x plus, and then instead of y, I'm going to write that because we know that y is the same thing as 4 minus x. So I'm going to put 4 minus x here. All right? Is equal to 7, right? Because that's just the rest of this equation. Was originally 2x plus y equals 7. This is 2x plus y equals 7 because this whole thing is y. And we got that information from equation 2, from over there, right? So now at this point, I don't really need the brackets because we've just got a plus sign. There's no like multiplication or anything going on here. So I'm just going to rewrite that a little bit neater. So we've got 2x plus 4 minus x is equal to 7, right? So that's where we are right now. 2x plus 4 minus x equals 7. And this guy right here, even without the brackets, this right here, that's the y from equation 2, right? That's the information we got from equation 2. So at this point, I'm just going to group the things with x's together, right? We got a 2x here, and then we got minus x over there. So 2x minus 1x, well, that's just 1x, right? And then we got plus 4, that's just this plus 4 right here, equals 7. With me so far? I hope so. Just spam the chat if I've lost you somewhere, but if the chat is quiet, I'm going to assume we're all good. So at this point, we've got x plus 4 equals 7. So at this point, you could probably guess what x is, but if you're not sure, well, we've got this plus 4 here. So you can just subtract 4 from this side and subtract 4 from that side, right? Just like what we did in the previous problem. And if you do that, this plus 4 and minus 4 are going to go away, and you're left with just x on the left-hand side. And then you've got 7 minus 4 on the right-hand side. So 7 minus 4 is 3. So from this information that we got way back in equation 2 at the very beginning of the problem, we plug that into equation 1, and you see that here in this line right here, there's no y's actually showing up anywhere. We've turned it into a one variable problem. So we've got x's in a couple of spots, but it's the same variable. So it's still a one variable problem, and we don't have any y's anywhere. So now we just solve that one variable problem. We get x equals 3. Now we have to use that information to figure out what y is. So we take the information that we just got from equation 1, and we're going to plug it back into equation 2. Now, equation 2, and we've already got an answer in the chat, equation 2 was y equals 4 minus x, right? That's what we had for equation 2. But we know that x is equal to 3. So I'm going to rewrite equation 2, and anywhere that I see an x, I'm going to replace it with a 3. And so we get that y is equal to 4 minus 3, which is equal to 1. And that's what we got in the chat. We got x is equal to 3 and y is equal to 1. So that's basically how all your problems with two variables are going to work. The only thing that's a little bit easier with this one compared to some of the ones that we've seen in class is that this equation was just ready to plug information into the other one, right? If I'd said this was like 2y, at the beginning, then you have to ignore all of this stuff because we have to start out by doing some work over here to get the y by itself. We got to divide out the 2, or we got to choose to isolate the x, or we got to change our approach a little bit if it's not so straightforward as one of the variables already being by itself. But that's the only thing that's easier about this problem, is that we didn't have to isolate either of the variables here. It was already done for us. So how are we doing? Thumbs up if you're good with that, thumbs down or a crying face or something if that made no sense whatsoever. All right, we got some thumbs ups. And if there's any problems with this, if we got thumbs downs or a crying face or anything, everyone die on the chat. Pretty much, yeah. Um, but yeah, so if there are problems with this, we got lots of time. It's only 8:20. We got time. We can do more examples of this. But somewhere in the middle, okay, that's fine. So tell you what, we'll do another one of these because this is actually, I would say, harder than the word problems. The only thing that's tricky when it comes to word problems is you have to read this paragraph and you have to pull out an equation from thin air, basically from the information in the paragraph. But after that, it's nothing harder than what we just did. Problems with two variables is the hardest actual math that we did. Word problems just add that extra step of you haven't been given the equation. So let's do another problem with two variables. And I'll make it a little bit harder so that we have to isolate one of the variables. So let's say something like this. How does that work? If I make that, mm, okay, I could make that number. I could make that number. And how about here? If I make this, if I make that. Mhm. Yeah, okay. So that would be this. Yeah, okay. So here are our two equations. So we've got 3x plus 2y equals 17. That's equation 1 over here. And then we got 2x plus 2y equals 14 over there. That's equation 2. All right, so I'm just going to label those as equation 1 and equation 2. If you prefer equation A, equation B, or something else, you're more than welcome to do that. Okay, so let's do this one. This one's a little bit harder because we have to isolate one of the variables in one of these equations. We're not going to be able to solve the problem without doing that, right? So I'm going to start with equation 2 pretty much because it's got smaller numbers. I don't know which equation is going to simplify more easily than the other one, but usually smaller numbers are a good sign. So what I'm going to do is we've got a 2x, we've got a 2y. It's going to be an equal amount of work to isolate either of them. I'm going to isolate the x. Why not? Just because. So if I want to isolate the x, I want to get rid of these two y's from the left-hand side of the equal sign in equation 2. So what I'm going to do is I'm going to subtract 2y from the left side, and I'm going to subtract 2y from the right side. Okay, so if I do that, then the left-hand side becomes just 2x, right? Because that plus 2y minus 2y are going to disappear, is equal to, and then we've got 14 minus 2y on the other side. Okay, that's where we are so far. Stick with me now. Here we've got a 2x. I would really love it if it was just x, right? With no other numbers attached to it, no multiplication, no addition, no nothing. So if I want to get this 2x into just x, I got to divide this side by 2, and I got to divide that whole side by 2. All right, so if I look at this left-hand side, we've got x times 2 divided by 2. So those 2's disappear. So we've got just x on this side. Now on the right-hand side, this thing is a little bit chaotic. This 14 minus 2y divided by 2. But actually, I'm going to show you something cool about this. This is a big fraction, right? Basically, we've got a division of two fractions. Let me show you. 14 over 2 minus 2y over 2. Now, that might throw you off. It might not, but if it does throw you off, what we did in our fractions unit is you would get something like this 14 over 2 minus something over 2, right? And then you would combine it into one big fraction with a common denominator, right? That's what we used to do in our fractions unit. Here, what I'm doing is I'm breaking it up. And I'm breaking it up because this 14 and this 2, I can divide out a 2 from both of those. So 2 divided by 2 is 1 on the bottom. 14 divided by 2, that's 7 on the top. And then over here, the two 2's just cancel. So if I rewrite this, we've got x is equal to, and then that's 7 minus y. Okay, now if I lost you with the simplifying here, don't stress out too much. I think you don't have to do anything quite like that on the test. I'm going to have to double check because I haven't actually made the answers yet. But I don't think you have to do anything quite like that on the test. But so the point is, at the end, what we've got from that equation 2 up there is, I did lose you? Okay, so ignore the simplifying. From that equation right there, basically all that happened is we had to do some work, right? We had to do a little bit of work to get this guy right here, x equals 7 minus y. All right, let's ignore all of that we just did and just focus on this answer. And we're going to see if we can solve the rest of the problem from here. Okay, so x equals 7 minus y. We're going to start with that. Now, this is what we got from equation 2. So we're going to take this information and we're going to plug it into equation 1. All right, so in equation 1, the x is going to be replaced by that, 7 minus y, right? Oh, let me turn on my light. It's getting a little bit dark in here. There we are. So we got x equals 7 minus y from equation 2. So we go over to equation 1, and anywhere that we see an x, we're going to write down 7 minus y instead. So this is going to become 3 multiplied by, instead of x, it's going to be 7 minus y plus 2y equals 17. Does that step there make sense? Taking this x equals 7 minus y and going to that? Give me thumbs ups in the chat if that step made sense, and give me thumbs down if it did not. From here, we have to do a little bit of work to unpack this guy right here. So let's take a closer look. Let's kind of zoom into that piece right there. So we've got 3 times 7 minus y. I'm going to show you guys properly how the distributive property works here. All right. So if you're lost at how we got from this to that, this whole equation right here is basically just that whole equation right there. All I've done is wherever there's an x, I've written it as 7 minus y, because over here we said that x is the same as 7 minus y. Okay, now we're going to look at this bit right here, 3 times 7 minus y. We're going to examine that. So this thing down here, we have to do what's called the distributive property. So what that's fancy terminology. You don't need to memorize those words. All that it means is that if you've got something on the outside multiplied by a couple of different things on the inside of the brackets, here's how you do it. You're going to take this thing on the outside and you're going to multiply it by each thing inside the brackets one at a time. So we're going to start like that. So we're going to you can even draw the arrows in when you're doing the test. You can draw the arrows in and do the multiplication that way. So if we do this multiplication, we do 3 times 7 is 21. 3 times y is 3y. And then we keep that minus sign there in the middle because there's no other sort of funny business going on. Cool. So we've got 21 minus 3y. That's this piece right here in this rectangle right there. So we've got, I'm going to rewrite that just below. So we found that thing at the beginning, that 3 multiplied by 7 minus y, that is 21 minus 3y. So I'm going to write that as 21 minus 3y plus 2y. That's just this piece right here coming down, equals 17. So we got 21 minus 3y plus 2y equals 17. That's what we got in the chat as well. So now I'm going to group the y's together, right? Negative 3y plus 2y. Well, that's going to be negative 1y. So I'm going to write that as negative y. And then we've got this 21 still in front, and we got equals 17 on the other side. Right now, I don't really want to deal with this negative y. I would love it if my variable had a plus sign in front of it. So what I'm going to do is I'm going to add y to both sides. So if I add y here and I add y there, then on the left-hand side, all the y's disappear. We got negative y, we got positive y, they vanish. We're left with 21 equals, and then on the other side, we have 17 plus y, right? That's 21 equals 17 plus y. Now, I don't want y added to 17. I want y by itself. So I'm going to subtract 17 from the right side, and I'm going to subtract 17 from the left side. Yeah, well, we'll do some more. We'll do some more after this for sure. So what we get here is we find that y is equal to 4, right? We get rid of the 17s from that side. We're left with just a y. And then 21 minus 17 is 4. So we get that y is equal to 4. That's what we got there. Now we have to take that information and we have to plug it back into equation number 2. And so basically we have to plug it back into this guy right here. So we say that x is equal to 7 minus y. We got that earlier. And now we know that y is equal to 4. So that means that x is going to be 7 minus y, but we know that y is 4. So I'm going to put a 4 there instead of a y. And 7 minus 4 is 3. And so we get that x is equal to 3 and y is equal to 4. Now, I've got a question for you guys. I know that's a lot of math and it's all stuffed onto one little whiteboard here. Did that general process make sense? Not every single step of like, oh, I'm going to break the fractions and then I'm going to do the distributive property, ignoring those little like sort of nitty-gritty details. Did that general process make sense? First, what we did is we isolated x. So I'm going to walk you through the process of all this mess that's on here. So we started with equation 2. We isolated x. Then we took that number for x. We went over to the other equation, and anywhere that we saw an x, we wrote down that thing that we found, 7 minus y. From that, we've got this equation that doesn't have any x's in it. It's got some y's and it's got some numbers. And then we figured out what y is. Okay, I'm getting a lot of not reallys in the chat, so maybe we'll do one that's a little bit easier than this and a little bit more like the first one that we did. Let's do that because I think this one was a slight step too far. And let me actually also check whether there's anything quite this hard on the test, because I'll give you something that's equally hard to the hardest one that you will find on the test. Let me just check the test real quick. Okay. The first problem we did that one make sense when we didn't have to isolate one of the variables or when we didn't have to do a lot of work at that first step? Because if so, we'll do another one like it. But if this next problem makes sense, you don't have to worry about the two variable problems on the test because you're never going to have both variables always attached to numbers. There's always a variable somewhere by itself. So let's do one. I'm going to I'm not going to copy the question from the test, but I'm going to show you sort of roughly how, the kind of difficulty we're looking at. So let me come up with one. So let's do, no, that's too big of a number. Let's do something like, so if I say that is something like that, let's say. And then if that is, okay. And then I can say, I think, let me see if that works out with nice numbers. So if that's, mm-hmm, yeah. Oh, so that should be a different number. So that's, okay, here's our new question. Here's our new question. So we got these two equations. So equation one, this first one over here, that's 4x minus y equals 1. The second one, 2x plus 2y equals 18. Now, normally, when I make these questions, normally I come up with some expression where I've stuck a bunch of x's and y's together, and I've got some idea of like, okay, I'm going to make x equal to 5 and y equal to 10. And then I tell you in the other equation, x plus y equals 15 because I told you that x is 5, but like because I decided that x is 5 and y is 10. So the second equation, normally in most of the examples that we've done, the second equation is the easier one. But in this case, the second equation, we've got the x is stuck to a 2, the y is stuck to a 2. We got some big numbers going on. I don't really like it. The first equation, we got a 4, we got a 1, we got some nice small numbers, and we got a y without any numbers attached to it. So what do you guys say? Thumbs up if we isolate equation 1 instead of equation 2. So thumbs up for isolating equation 1. Or if it makes sense to you why I'm choosing to isolate in equation 1 instead of equation 2. So, what I'm going to do is I don't want to deal with the 4 being attached to the x. I'm going to isolate the y because it doesn't have any numbers attached to it. So, I only have to do a little bit of addition and subtraction, but I don't have to do any multiplication and division. So, no fractions, none of that nonsense here. Just addition and subtraction. So, I want this y to be by itself. But I don't really like that it's got this minus sign in front of it. So what I'm going to do is whenever I see the variable that I want to isolate, if it's got a minus sign, I'd like to add it to both sides so that it ends up on the other side of the equation or on the other side of the equal sign with a plus sign. So I'm going to do plus y in equation 1. So what that gets me is on the left-hand side, we've got 4x minus y plus y. So the minus y and the plus y disappear, and we have just 4x. On the right-hand side, we have 1 plus y. So 1 plus y. Not much to it. Right? Now, I don't want it to be 1 plus y. I want it to be just y. No ones, no nothing, no numbers, just a y. So I don't want that 1 there. So what I'm going to do is I'm going to subtract 1 from that side. But if I subtract 1 from that side, then I have to subtract 1 from this side. Right? So what I end up with is the two ones disappear, and we're left with 4x minus 1 equals y. That's what we got, right? It looks very, very similar to what we started with, right? That was 4x minus y equals 1. Now we got 4x minus 1 equals y. But what we have is the y is by itself. So what is this telling us? This is telling us that anywhere that you see a y in this problem, you can write it as 4x plus 1, which is bigger and more complicated. It's a harder way to write the y, but it doesn't use any y's in it. So if we use this expression right here, 4x minus 1 equals y, if we use that over in equation 2, we're not going to have any y's in the problem anymore. Hello. So what I'm going to do is I'm going to take this. So I'm going to just write it a little bit more neatly one more time. Y equals 4x minus 1. I just switched the order, but there's nothing wrong with doing that um, as long as you're not changing any signs. So we got y equals 4x minus 1. So now I go over to that equation there. So we had 2x plus 2y equals 18. But instead of y, I'm going to put 4x minus 1 because that's what we figured out over here. Thumbs up if it's still making sense at this point. We figured out y equals 4x minus 1. I think we're all on board with that. And then I'm going to write that 4x minus 1 right here. 4x minus 1. We got a thumbs up. Hopefully we get some more thumbs ups. But so now, if we look at that expression right there, this last line up here, you see how we got an x here and we got an x there, but we don't have any y's, right? So now that's a one variable problem, right? This is a problem with just x's. There's only one kind of variable. Sure, it shows up 2 times, but it's only the one variable. And we know how to solve those problems because we did one of those earlier, of course, unless you've joined us a little bit later. But so now we're going to take a close look at that distributive property thing again, right? I'm going to just zoom in on this piece right here, that 2 times 4x minus 1. We're just going to zoom in on that for a sec. 2 times 4x minus 1, this guy right here. So I'm going to draw in those arrows. We're taking the guy on the outside, this 2, and we're going to multiply it by that on the inside. We're going to multiply it by that on the inside, and we're going to keep the minus sign in between. So 2 times 4x is going to be 8x. 2 times 1 is 2. And we keep the minus sign in between. Okay, so that's what we got here. We got 2 times 4x, that's 8x. 2 times 1 is 2. And this minus sign is that minus sign. Cool, so this 8x minus 2, that is this guy right here. This 2 times 4x minus 1, that's this, 8x minus 2. So what I'm going to do is I'm going to rewrite that line with this 8x minus 2 in there. So I'm just going to erase a little bit. So we've got 2x plus, and then we said that that whole thing there was 8x minus 2 equals 18. Cool? Yeah, and we've got that in the chat as well. 2x plus 8x minus 2 equals 18. Cool. Now we're going to group the x's together. We got 2 x's and we got 8 x's, and they're being added together. 2x plus 8x, 2 apples plus 8 apples. That's going to be 10 apples. That's going to be 2x plus 8x is 10x minus 2 equals 18. And now remember, I said if you've got a number and a letter attached together, treat those as one object. So we're not going to break apart this 10x just yet because we've still got this minus 2 hanging on. So what we're going to do is we're going to get rid of that minus 2 by adding 2. But we have to add it to both sides because otherwise we're changing the question. So if we do that, the minus 2 and the plus 2 disappear, and we're left with 10x equals 18 plus 2 is 20. That's a pretty badly written 2, but that's 20, right? 18 plus 2 is 20. So we got 10x equals 20. And now we don't want 10x, we want just x by itself. So I'm going to divide by 10, and we get x equals 20 divided by 10 is 2. So all of that work, and we're almost done. We're not completely done yet. We started all the way back at the beginning. We figured out what y is in terms of x, right? We figured out how to write y using x's and numbers. Then we went over to the other equation. We did all this work, and we got x equals 2. Now we're going to take that information, we're going to plug it back into this thing that we found over here, y equals 4x minus 1. Well, we know what x is now. So now we can figure out what y is using that information. So if we do that, I'm going to put that right in the middle here. Y equals 4x minus 1. But what is x? X is 2. So instead of x, I'm going to put a little 2 there. So that's a 4, and then that's a 2 in brackets for like multiplication. 4 times 2 minus 1. Well, what's 4 times 2? 4 times 2 is 8. Minus 1 is 7. So we get that y equals 7. And that's your answer. We figured out that x is 2 and y is 7. Did that problem make complete sense, a lot of sense, a little bit of sense, or no sense at all? Give me some emojis, give me something in the chat, give me words in the chat. How are you feeling with the problem that we just did? If you dropped in halfway through the problem, that's okay. Obviously, you're not going to get it completely perfectly if you dropped in halfway through the question. But okay, a little bit of sense. Okay, so a couple of you are starting to feel better with that. Your brain is finally functioning now. Awesome. That's what I like to hear. My brain is almost not functioning because it's the end of the day. But so the question that we just did, and we can do more for those of you that want to stay if there's still things that aren't making complete sense. I'm happy to stay and do more past the hour. We still got some time. We still got 15 minutes before we're technically done. Um, but the questions on the test are not harder than that. So I'm not going to show you the questions on the test, obviously, but there's always at least one variable that when you have to do the isolating way back at the in the first step, it doesn't have any numbers attached to it. So you just have to do some addition and subtraction. You'll get something like this guy. It might not look the same as this 4x minus 1, but you'll get it, it'll be relatively easy to get from the first bit to this bit, which you plug it into the other equation, you figure out that other variable, and then you come back and you figure out the first variable. What do you mean you don't believe me? What about it? What about what I said that you don't believe? Oh, can I dropped in the middle of that one? Can you do another one? Absolutely. Let's do another one. So you might have also missed what I said about the how hard the test questions are going to be. So I tried to do one example before that where all the variables in all instances had numbers attached to them, and that was a nightmare um to try and like isolate the variables. So I went and I checked the test, and we don't have any questions on the test where all the variables have numbers attached to them. There's always at least one variable sitting by itself with no numbers attached to it. Okay, can we get some practice problems to see if I can do it on my own? So what I'm going to do is I'm going to write a new problem on the whiteboard, and then for those of you that have dropped in part way or it's still not making complete sense, you're going to do the problem with me. For everybody else who is like kind of ready to see if they can do it on their own, I'm going to write the problem on the board. I want you to copy down the equations and then mute your computer or mute your phone and see if you can solve it on your own without looking at what I'm doing. Does that make sense? Also, can we practice exponents? We will practice exponents at the end. Um, so yeah, let's do one more of these. Then we'll hop over to exponents for a bit, and then we can come back to this for anyone who needs to stay and do some more. So let me come up with a new question. Um, let's pick some different numbers. Okay, and we'll say does that work? Does that give nice numbers? Yes, that would be that. And then if I, oops. Okay, so for those of you that want to try it by yourself, write down these two equations and then mute whatever device you're watching me on and try not to look at the screen unless you get stuck. And then for those of you that, if you dropped in halfway, if you're not sure exactly what was going on in all of the last question, um, then follow along with me. And obviously, if you try to do it by yourself and you get stuck, jump back and follow along with me. So here are your two equations. 3x plus 5y equals 13. X plus 2y equals 5. So I'm going to start solving it now. So if you want to solve it on your own, now is your time to mute me. So I'm going to call this first one equation 1, and I'm going to call that second one equation 2. It's always useful to number the equations just so that you can kind of talk about them as you're going through the problem. Now, in equation 1, the x is stuck to a number and the y is stuck to a number. I don't like that. I don't want to isolate a variable that's already stuck to a number. But if I look at equation 2, this x doesn't have any numbers stuck to it. So that's the one that I want to isolate. right? And if you dropped in late, um, generally, my strategy, if I have to solve a question like this, I like to isolate the variable in the equation that's got a bunch of smaller numbers anyway. So this one, we've got a 13. I already don't like it. This one, the biggest number we have is a 5. Nobody's scared of the number 5. I'm going to try and isolate in this one. So what I'm going to do is I'm going to start in equation number 2, and I'm going to isolate the x because it's by itself. It doesn't have any numbers attached to it. It shouldn't be too hard to isolate. So that's how I'm choosing which variable I'm going to pick. Technically, you can do any of them, but it just gets harder if the variable has numbers attached to it. And if it's got bigger numbers attached to it, it just gets harder. So I'm going to isolate this x. Now, what does it mean to isolate it? I don't want this 2y to be on the same side of the equal sign as this x. You see, right now they're both on the left side of the equal sign. I don't like that. I want this 2y to go over to the other side of the equal sign. How am I going to do that? I'm going to subtract 2y from this side to get rid of it from the left-hand side. But that also means that I have to subtract 2y from the other side of the equation because otherwise I'd be changing the question. So when I do that, this plus 2y and this minus 2y, they're going to disappear. You didn't get a nice number. Interesting. It should work out. It should work out. Let me see. Let me see. And try following along with me and see if you can spot the mistake, or maybe they're going to turn out to not be nice numbers. So these two y's, they vanish from that side. Um, ew, 11y is 28. That's pretty scary. Okay, try following along with me and see if you can figure out where you went wrong. Um, So those two y's disappear. So we're left with just an x on the left-hand side. And on the right-hand side, we have 5 minus 2y, right? Because we had the 5 and then we subtracted 2y from both sides. So we've got x is equal to 5 minus 2y. That's the end of isolating x, right? Because now we've got the x all by itself. Awesome. So that part, fantastic. So if you can do that step, you're well on your way to solving the problem because the next step is we figured out that this x can be written as 5 minus 2y. So what that means is I can now go over to the other equation, and wherever I see an x, I'm going to write down 5 minus 2y. That's the whole point of this first step, is so that when we go to the other equation, the variable that we isolated, so in this case the x, wherever we see an x in the other equation, we're going to write 5 minus 2y. So if we rewrite this equation, we've got 3 times x, but x is 5 minus 2y. And then we've still got this plus 5y, right? That's this plus 5y here, this plus 5y here, equals 13. Okay, so that's what we have right now. And if you notice, this equation, it's got some y's in it, but it doesn't have any x's in it. So this is a one variable problem because there's only one type of variable, only one kind of letter. We've got a couple of y's, but that's it, no x's. So now we're going to zoom in on this piece right here, this 3 times 5 minus 2y. We're going to zoom in on that, and we're going to do that distributive property thing again. So we've got 3 times 5 minus 2y. So how does that work? You're going to take the guy on the outside, you're going to multiply it by each piece on the inside one at a time, and then whatever sign you have in the middle, you're just going to keep that. So 3 times 5 is 15. 3 times 2y is 6y. And we had a minus sign in the middle. The minus sign would only change to a plus sign if you also had a minus sign out here. Then all the signs on the inside would flip. But if you've got a positive number out here, you don't have to change any of the signs on the inside. So that minus sign is this minus sign right here. You got a worse answer now. 11y equals 2. Okay, try following along with me. See if you can figure out kind of if you have the same stuff as me so far. So this piece right here, 3 times 5 minus 2y, that's this thing that we worked out down here. 3 times 5 minus 2y, that's this, 15 minus 6y. So what I'm going to do is I'm going to go back up to this line here. I'm going to rewrite it, but instead of 3 times 5 minus 2y, I'm going to write this 15 minus 6y. So if I do that, so instead of that, I'm going to write 15 minus 6y. And then I still have to write the rest of this. So we've got plus 5y equals 13. Do we need to memorize the exponent rules for the test? Yes. Not all of them, but the product rule, the quotient rule, and the power rule. So the first three, I think, that we went through, you should know those. Yeah, so now we've got this 15 minus 6y plus 5y equals 13. All right, I'm going to get rid of this guy down here because we don't need it anymore. Now I'm going to group together all the y's. So we got minus 6y plus 5y. Well, that's minus 1y, right? Like negative 6 plus 5 is negative 1. So that's negative 1y. And then we still have this 15 in front. And we still have equals 13 on the other side, right? Now, again, I don't like having a minus sign in front of my letter. So when that happens, I'm going to add y to this side. I'm going to add y to that side. And what happens is on the left-hand side, these y's disappear. So minus y and plus y disappear. We're left with just 15. And on the other side, we've got 13 plus y. You got y equals 10. Interesting. All right, let's see if we can figure out what went wrong. But so at this point, I've got 15 equals 13 plus y. So you can see from that, or if you want, you can subtract 13 from both sides, and you'll get that y equals 2 is the answer that you should have gotten for this first step, is y equals 2. All right, and then from that, if you're still following, where did the extra y come from? Which extra y? This one? Okay, so that came from, so what we had was we had 15 minus y equals 13. And then what I did was I added y to this side and I added y to that side. So we got plus y here, plus y there, and these y's disappear. So we're left with just a 15 equals 13 plus y. That's where that extra y came from. So now, and then from that, we get that y equals 2. Now you got that answer. Awesome. Okay. So cool. So now from that, from this y equals 2, now we got to go back to the other equation because we still have to figure out what x is. So we got to go back to this thing in this box right here. So we said that x equals 5 minus 2y. But now we know that y is equal to 2. So instead of y, I'm going to put a 2 there. And putting a number in brackets, that's just, it's multiplication, right? Because it was 2 times y there. So it's 2 times 2 here. 2 times 2 is 4. So we've got 5 minus 4. So x is equal to 1. So this problem, the answers to this are x equals 1 and y equals 2. Thumbs up in the chat if you got that right, or if you at least followed along with what I was doing. Got a thumbs up? Got at the end of it. Yeah, that's okay. That happens. So the way you can always check is if you got like y equals 10, if you got y equals 2/11ths or like weird numbers, what you can always do is go back to the original equations and plug in your answers. Plug in y equals 10 and x equals whatever you get as your answer for x, and see if it makes sense in both equations, that left-hand side equals right-hand side. If it doesn't, you automatically know that you've done it wrong. Still struggle a bit in how to isolate the letters. That happens. So I can give you some tips on that. We did have some questions about the exponents, so I will just quickly, we'll pop over to talk about the exponents for uh, okay, actually, what would you guys prefer? Would you rather we practice isolating a variable, or would you rather we talk about exponents for like 5 minutes? and then come back to it. Yes, please, to which one? Isolating variables? Okay. Okay, let's do isolating variables. To isolate? Cool, 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 cool. All right, yeah, let's practice isolating variables, and then I'm good to stay on for like 2.5 hours. If you guys need the help, I am more than happy to stay on and help you guys out. Um, so don't worry about the time unless you have to go at some point, but I am good to stay here and keep giving you examples until my markers run dry. So suppose I give you guys something like, so we want to isolate, right? So, oh, then I'm going to give you something like what's on the test. So exponents are easy. Okay. um, okay, so I'm not giving you two equations. I'm giving you just one equation, just so we can practice that first step of isolating, right? So right now, we do not have enough information on here to figure out what both x and y are because you need to have two equations for that. So right now, we don't know. But what we're going to do is we're going to practice isolating. And you know what? Uh, maybe that's a little too easy. I think this is a little too easy, but we can start with this, and if it is too easy, then I'll do a harder one. So I personally, looking at this, I would like to isolate. No, 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 not too easy. Um, this is good. Okay, so I personally would like to isolate the y because it doesn't have any numbers attached to it. So I could isolate the x if I wanted to, but I'm going to have this extra 2 that I have to worry about all the way up until my very last step. I don't like that. I'd like to worry about less. So I'm going to keep this, I'm going to isolate this y. Now, I don't want this y to isolate, just the word isolate. You guys would have heard this during COVID times, right? You get sick with, you think you have COVID, you have to isolate. That means you have to be away from everything else. That's what it means for something to be isolated is it's away from everything else. It's separated from everything else. There's a little bit of distance between you and the entire rest of the world. We want to do that to this y. This y has COVID and we want it to be self-isolating away from everybody else. So this y, in order to get it by itself, that means we don't want to have this 2x kicking around on the same side of the equal sign. So how are we going to get rid of it? Well, right now we've got with addition, you can do it in either direction. So this is 2x plus y is the same thing as y plus 2x. I don't want y plus 2x. I want y with nothing on the same side of the equal sign. Yes, it would. Yes, it would. So I'm going to show you the way I have been teaching it for most of our class, and then I'm going to give you the shortcut. So the way I've been teaching it in class is if you've got y plus 2x, 2x plus y, and you want the y by itself, this 2x, it's got like a little invisible plus sign in front of it because we don't write the plus sign in front of a positive number most of the time. So we've got this positive 2x, this plus 2x going on in this side of the equation that we don't want. We don't want the 2x over here. So basically, ignoring the entire rest of the world, we say, I don't want y plus 2x. I want y by itself. So I am going to subtract 2x and I will deal with the consequences later. So we've got 2x plus y minus 2x. Now we have to deal with the consequences of that. This is an equation. We've got an equal sign here, which says that this side is equal to that side. If we've taken something away from here, that's like you put something on a balance and you took 2x off one side. So you have to take 2x off the other side, or else it won't be equal anymore. So we have to subtract 2x over there as well. So right now, this left-hand side, we got a y, we got a positive 2x, we got a negative 2x, all being smushed together. This plus 2x and this minus 2x cancel each other out. They disappear. That's the whole point of us subtracting the 2x is that they disappear from here. So we're left with just y on the left-hand side. And on the right-hand side, we just rewrite whatever we have, 15 minus 2x. And that's it. We've isolated y. It's completely by itself on one side of the equal sign. And then if you had a second equation, you take this thing, this y equals 15 minus 2x, and you yeet it into the other equation, and then you're good to go, and you can solve for x. Now, this is the way I've been teaching it so far. You subtract 2x from this side, you subtract 2x from that side, you get this expression, and now you've isolated y. Now I'm going to show you the shortcut. It's the exact same result, obviously, because otherwise it wouldn't be a shortcut. It would just be a different thing that you're doing. 2x plus y equals 15. The shortcut is that if you've got like two things being added together, like this y and this 2x being added together over here, I don't want this 2x on this side of the equation. I'm literally going to take this 2x and I'm going to throw it on that side of the equal sign. So I'm going to take this 2x, get rid of it from here. I'm going to put it over there. The only rule is that if you had a positive number here, it's going to become a negative number there. If you had a negative number here, it's going to become a positive number there. So by throwing it onto the other side of the equal sign, the only thing you have to remember is that a positive sign becomes a negative sign. So you flip the sign of the number if there is a number. Or if it was just an x, now it'll be negative x. It'll be minus x. So we get the same thing. Y, we don't need this plus sign anymore. Y equals 15 minus 2x. If that shortcut is easier, you can do that. The way I have done math ever since I learned this shortcut is the shortcut. I take a number from one side of the equal sign, I chuck it to the other side of the equal sign without a care in the world, and I flip the sign of the number. So it was a positive 2x before, now it's a negative 2x. And that's it. And this math that we've been doing of like subtracting 2x from this side and subtracting 2x from that side, that's the actual math that's going on underneath. That's why we end up with this answer with the flipped sign. Yeah, if you like the old way better, do the old way. And I will keep doing the old way because it's clearer, but the new way is faster. So when you get more comfortable with doing problems like this, you'll end up automatically switching over to the new way just because it's faster. And you're going to, once you understand the math that's going on in the background, then you don't need to write it down every time. But right now, if you like the old way, if you like the way I did it first, do that. But how are we feeling with isolating? Thumbs up if you're good, uh, crying faces if you're not so good, and anything else if you're like on the fence, if you're not sure. Cool. We got some affirmatives. Cool. Lots of thumbs ups. Lots of thumbs ups. Thumbs up? Thumb ups? I don't know what the plural is. But anyway, lots of thumbs ups. So, I did have a question way back earlier. I hope whoever asked, yeah, can we do practice problems? Do you want what kind of practice problems? Like word problems or just like practice equations that you can work on? Variables? Okay, stuff with variables. Okay, so what I will do is I'll give you another two variable. Cool. I'll give you another two variable thing. Um, let's make it interesting. I'll give you that number. Mm, Okay, so what I will do is I will give you these two equations. You guys can take a few minutes to work on it. And if anybody else, if you've got other questions, then I can help you with that in the meantime while everyone is working on this. It should be possible to take the test Thursday. If you're just yeah, if you're not there on Tuesday, then yeah, just pick up the test from one of your teachers. Either on they might let you take it on Wednesday and do it at home. They might I don't know how they're gonna run it. But yeah, that's something that you'll have to ask them because I don't have any control over that. I just gotta make the answer sheet and send it to the teacher so that they can mark. But yeah, you can ask them. It'll be fine to do the test later for sure. Do you guys want me to work through this problem as well, or do you want me to just give you the answer when you're done? Or do you do X or Y first? It's up to you. So if you look at this second equation over here, neither the X nor the Y has a number attached to it. So it's going to be uh, equally easy or equally hard to isolate either of them. You never have to do one of the two variables. You could isolate this X, you could isolate this Y, or you could isolate this X or this Y. It's completely up to you. I always just pick whatever's easiest for me, which sometimes it's the X, sometimes it's the Y. If it's like you don't have to do alphabetical order or anything like that. Whatever you want. 24 minus 4y minus 2y equals 0. Okay, so you isolated the X. Okay, so you're stuck there. Okay, so your next step is you see you've got the minus 4y minus 2y. You got to smush those together. So like minus 4 minus 2, or like negative 4 minus 2 is negative 6. So those two terms smush together to become a negative 6y. You don't even know where to start? Okay, so tell you what, I will work through this problem alongside. And those of you that are working through it, yep, there you go. 24 minus 6y equals 0. And then now, if you don't like the minus sign in front of your y's, you can add 6y to both sides. Okay, yeah. So if you don't know where to start, I'm going to work through this problem alongside. And everybody else who is, I think that's right. Yeah, I think you're both on the right track right now. Um, Yeah, so if you're working through the problem, mute me. I'm going to take a few minutes or follow along if you're already done. So I'm going to start by isolating X, just because I feel like that's what you guys have done, but I'm going to isolate the X just because why not? It's equally easy or hard to isolate the X or the Y in equation two. This is equation one, that's equation two. So yep, you're on the right track. And then you just have to you don't have to write the 0 anymore. So it's just 24 equals 6y and then divide both sides by 6. But anyway, I'm going to go back to solving it. So x plus y equals 6. I'm going to start by isolating x. So that means I don't want the y right here. I don't want the y on the same side of the equal sign as the x. Good job. I like that. I like what I'm seeing in the comments. So x plus y, I don't want plus y. I want just the x. So I'm going to subtract y from this side. But if I subtract y from here, I have to subtract y from the other side as well. So we're going to get this plus y and this minus y vanish. And we're left with x by itself on the left-hand side equals 6 minus y on the right-hand side. So that's isolating for x. That's what we get. X equals 6 minus y. Would you get different answers depending on which letter you choose? No, you would not. You should get, if you've done it right, you should get the same answers no matter what. That's the beauty of you have when I say that like you can isolate whatever you want, that means it won't change the answer. So yeah, so in isolating the x, I subtracted y from both sides and we got x equals 6 minus y. So I'm going to come over here. So x does equal 2. I think so. Yeah. We will see in just a sec because I'm working through it here as well. So we've got x equals 6 minus y. Coming over here, anywhere that I see an x, I'm going to write down 6 minus y instead. So this 4 times x is going to be 4 times 6 minus y minus 2y equals 0. Cool. Now this bit here, we have to do the distributive property. So 4 times 6 minus y. 4 times 6, that's 24. 24. 4 times y, that's 4y with a minus sign in between. We just keep that minus sign from right there. So here we have 24 minus 4y minus 2y equals 0. And from there, that's what you have. You have to go soon. Okay, I'm going to speed through this then. So 24 minus 4y minus 2y. This negative 4y minus 2y, that's negative 6, right? And minus 4 minus 2 is minus 6. This 24 keeps kicking out in front. Now, I don't like the 6 having a minus sign in front of it, so I'm going to add 6y here. I'm going to add 6y there. And so these disappear. And so what I'm left with is I get 24 equals 6y, right? Because it was 0 before, so I don't need to write 0 plus. It's just 6y. 24 equals 6y. You divide both sides by 6, and you get y equals 4. And then you go over back to what we started with. We had x equals 6 minus y, but we know that y is equal to 4. So I put a 4 there. X equals 6 minus 4. X equals 2. You think you have to go 2? All right. So before you go, how are we feeling? Thumbs up if you're feeling good about these last couple of problems that we did. Because this is as hard as the test gets. Unfortunately, I didn't get to talk about word problems yet. If anybody is still here who wants to go over word problems, I'm happy to. But if not, and if you want to do some extra word problem, I lost bedtime. I know. Yeah, I wish I could have done this sooner. It's just that I finished work at 5, and there was a chance that I was gonna run late, so I didn't want to promised that I could do the review session earlier. Um, but yeah, if you guys are panicking in the morning, send me a message on the Instagram because I will get notifications of that. And I could do one of these in the morning if you're absolutely like stressing out. But how are we feeling about what we've seen this evening? Are we feeling better than earlier? Because this, except for the word problems, this is as hard as the test gets. So if you can do a question like this, you can do the test. If you can almost do this, you can do the rest of the test and you'll get most of the marks here. The only thing I have to remind you is when you're working through the test, show all of this stuff. Let it be messy and confusing. Write stuff down. Every mathematical thought that you have, write it down on paper so that whoever is marking it can see, oh, that was the logic. Oh, that was the steps that you were doing. All right. Yeah, so I am gonna hang out until I see the viewer counter drop to 0 because I know bedtimes. I'm sorry. I wish I could have done this sooner. Um, but I'm glad that you guys are starting to feel better about it. Uh, yeah, and if you have questions, if you're really, really like stressed, message me in the morning on the Instagram account, or like get your parents to like I don't know, to message me on the Instagram account or something, and I should be awake by 6:30. So I can do 6:30 to, you know, 8:30 or whenever your class. I don't even remember when your guys' class is. I just record the videos. But yeah, I'm glad you guys are feeling better. If anyone is sticking around, feel free to ask more questions. But yeah, if you guys are going to bed, then have a good night and good luck on the test tomorrow. And you're going to do great because I appreciate you guys coming to the review session because that effort that you're putting in, that's a really good sign. You're very welcome. You are going to do great. You're all going to do great. I know it's hard and it gets stressful being in a test situation. Remember what you know. It's very math is very step by step. If you know the steps, if you know the logic, if you know what you're doing and why you're doing it, you can't mess up. Or view counter has gone from 2 to 5. Some extra practice problems for fun. Absolutely. Yeah. If yeah, whoever has time, whoever wants to stick around, absolutely. I can do more practice problems. Do you want me to solve them or do you want me to just give them and then give the answer? I mean, I should probably solve them, but let's use a different color just so the blue doesn't get exhausted. Let's do hmm. Okay, let's do that. Our view counter is up to 7. Who is tuning in at 9:20? All right. So, I think these numbers work. This is if that's that. Yeah. And if that's okay. So, whoever's sticking around, or if you have time for just the one more, here's your one more. So you can figure out what you'd like to isolate and where. I personally would isolate this x right here. Two reasons. One, it doesn't have any numbers attached to it. And two, this equation has smaller numbers than this equation. This equation has a 27. Big numbers are scary. I don't want big numbers. So I would isolate the x over there in equation 2. But it is totally up to you. So I will wait here so you can get a start on that, and then I will solve the problem myself as well. Okay, so I'm going to move the 2 up there just so it's not in my way. Now, in isolating this x in equation 2, this x right here, I don't like that it's got a plus 2y living with it. So I'm going to subtract 2y from this side, and I'm going to subtract 2y from the other side. So this plus 2y, this minus 2y disappear. Oh, oh no. Um, okay, yeah, so this is x plus 2y minus 2y, those disappear. So we're at x equals 14 minus 2y. So there we go. We've isolated for x here. Now we're going to take that, we're going to plug it into the other equation. So now we've got 3, and then instead of x, I'm going to put 14 minus 2y plus y equals 27. So a little bit of bad planning on my part, that we're going to have to do this kind of multiplication of 3 times 14, which is big and scary. But so we've got 3 times 14 minus 2y. This is just the distributive property bit. So 3 times 14, we can do some long multiplication. 14 times 3, 3 times 4 is 12, carry the 1, 3 times 1 is 3, plus 1 is 4, 42. Does that make sense? 14, 28, 42. Yes. So that's going to be, this is 42 minus 6y, right? 3 times 2y is 6y. So that's this guy down here, 42 minus 6y. That's just this first bit. Then we've got plus y equals 27. So I'm going to group those y's together because we've got negative 6y plus y. So that's negative 5y. We got a 42 in front. We got equals 27 over there. Yep, I like that. So now I don't like that this 5y has got a minus sign in front of it. I don't like when my variable has a minus sign in front of it. So I'm going to add 5y to both sides. So they disappear from the left. So we're left with 42 equals 27 plus 5y. And then now I don't like, you're stuck there. Okay. Now I don't like that we've got this plus 27 going on. So I'm going to subtract 27 from both sides. 42 minus 27 should be, is that 15? Should be 15. Yeah. And if you have to do long subtraction, you can do long subtraction as well. 12 minus 7 is 5. 3 minus 2 is 1. There we go. 15 equals 5y because the 27s disappear. So we get 15 equals 5y. So that tells us that y equals 3. So there we go. Y equals 3. Now we're going to take that. We're going to plug it in to that equation from way back at the beginning. So x equals, it was 14 minus 2y. Now, instead of a y, I'm going to write 3 because that's what we found here. So 2 times 3 is 6. So x is equal to 14 minus 6. So x is equal to 8. There you go. And that's what's in the chat. Very nice. Very nicely done. And you should. Yeah, this is not easy math. This is the kind of math, like, I'm going to be honest with you. I did I did like I spent 6 years in university. Um and most of the time that I was there, I spent on physics courses. A lot of your time in physics courses, you're doing this. You're doing algebra. You like, sure, the concepts are like you're talking about like really confusing real world things, but the actual math that you're doing after the first few steps of the question, it's a whole bunch of algebra. It's so algebra is like a really really powerful got there in the end. Awesome. Um yeah, if you can do this, that's no joke because there's a lot of people that can't do this. So if you are able to, that's awesome. Um how are we feeling? And how much time have we got? Because it is round about 9:30. Los bedtimes. Yeah. How are we feeling about this kind of question? Everyone that's still here. Oh no. Without insulting anyone in particular, just insulting the whole class in general. You got to go in 5 minutes. All right. Do you have any burning last minute questions? Because I think if you solve this question right, I think you're pretty set for the test. I will tell you what the biggest number on the test is. Um, okay, so the biggest number that shows up on these problems of solving for like x and y given two equations, the Give me an extra hour. That's awesome. Okay. Um, so the biggest number that shows up on the test is 48, which, okay, it's a little bit bigger than the numbers we dealt with, but we dealt with some big numbers in this question, and you solved that question about as fast as I did. So I'd say you're fine. Um, the questions really don't get that much harder on the test than what we've done today. Honestly, I'd say they're probably not as hard, or they're equally as hard as the one we just did here. So if you're comfortable with this one, you are set for this part of the test. That being said, if you have questions about word problems, if you have questions about exponents, if you have questions about anything at all, that's what I'm here for. I'm going to give you a sec to do that. Word problems with two variables. Okay, so let me. So because you have to go in 5 minutes, I'm not going to have time to like come up with a word problem, write it down, and solve it. Um, but what I can do is I can give you some general tips for the problems with two variables. So, um, so the thing with word problems in general, the tricky part is figuring out what your uh what your two equations are going to be, right? Because you have to read a paragraph and you have to pull out math from words, which is like what? What is there the most of on the test? Okay, let me tell you that first. So we got um four questions of solving for one variable. So like it's like one question with four parts. So four separate problems where you have to solve for one variable. So that's like an algebra problem with just an x in it. Then you got four questions with exponents. Then you got three questions with problems of two variables. And then you got three word problems. Two word problems are one variable, one word problem is two variables. Now, in terms of the tips on how to do word problems with two variables. So, a lot of the times, what you'll find with the word problems is I will tell you something like, I'll tell you something like, so what I do when I come up with the equation, so I what I do when I make the word problems is I come up with something like this, right? I come up with an equation, something like this, and then I say, okay, I want y to be equal to 2 and x to be equal to 1. So I say, okay, if y is equal to 2 and x is equal to 1, then this is 2 plus 6 equals 8. All the math works out. And then to tell you that x and y are going to be 1 and 2, your second equation ends up being x plus y equals 3. So what I do when I make the questions is I do something like this, and then I turn it into words. So I'll do something like so and so is I don't know, selling shirts and pants, and they sell shirts for $2 and pants for $3 or something, right? And then I'll tell you a piece of information somewhere that's like, oh, the total number of articles of clothing that they sold is three, or whatever number is there. That's usually going to be your signal when I tell you, oh, the total number of this and that is 25. That's going to be your x plus y equals 25. X plus y equals whatever that number is that I give you. Chances are, if you see something like that on the test, that's like, oh, the total. I don't even remember what the word problems are that I put on the test. But if you see something like that, that's like, oh, the total of this and that is 100. Chances are one of your two equations is x plus y is 100. So that's one thing. And then the other thing, the other equation would come out of something that's more like what we saw when we did problems with one variable and like word problems with one variable, is it would be stuff like, gee, I can't even think of an example. But it would be something like I'm telling you that like, oh, you like what I said before, that it's like you sell shirts for $2 and pants for $3, and then you have to say, okay, well, let X be the number of shirts sold and let Y be the number of pants sold, and then you made $8. And it's like, okay, great. And then the total number of articles of clothing sold was three. Like it'll be something like that. A lot of my word problems have very, very similar wording because I'm not very creative. So I hope that helps with like kind of pulling the numbers out of the text. Um, yeah, but if you want some more practice, uh, in like with the short time that we have now, your best bet would be to look back at the videos and look at how I pull the math out of the word problems, especially for the problems with two variables. One of the lessons towards the end, I was like underlining that like this sentence right here is where I'm pulling out this math from. So if you want to take a second look at that, that would probably be your best bet. And the other thing you have to remember with word problems is uh, I don't give you the equations. So you can't just write down these two equations without telling me what X and Y are. You got to say, let X be the number of shirts, let Y be the number of pairs of pants. And then at the end of your problem, you have to say, therefore, one shirt and two pairs of pants were sold. Like you got to give me some sentences because that's how word problems work. Now that's not going to be too much of the marks. So if it's like a 5 mark question, four of the marks are going to be for the math, and one of the marks is going to be did you write sentences communicating your answer to the question? Because if the question is presented to you in words of how many pairs of pants were sold, then you should answer the question with a sentence. 3 pairs of pants were sold, right? So that's the only thing you gotta kinda watch out for, but I put that warning on the test that I say, "Remember to write your let statements, write your therefore statements." So, hopefully, you won't have to memorize that. I've given you that warning on the test in writing. You're very welcome. And yes, it is bedtime. The most important thing at this stage is you've done some practice, you've done your studying. Now you need a good night's sleep. And I know it's like, oh, math test, stressful. I know, I know. So try and get some sleep. Now is the time to go and get some rest because it might take a little while to fall asleep. And I totally understand that. But if you're panicking, have somebody reach out to me on Instagram. I will be awake by 6:30, no later tomorrow morning. And I will be available to help right up until test time. Awesome. Excellent. Yeah, that's a good idea. If you have the time for that. Bye. Good night and good luck tomorrow. You guys are going to do great. I'm going to hang around in case anybody else is also still I mean it still says there's 3 people watching, but I don't know if that's 3 of you from the class or 3 of you from around the world. So, hello, whoever's out there. But yeah, if you're off to bed, which you should be, then good night, and I will hang out here until the viewer count drops to 0 and stays at 0 for a couple minutes. Good night, buenas noches, and good luck. Good night, and you're very welcome.